facility end users. It actually helps to capture and manage data, the surveying data, and transfer the real world into digital reality. That is where the next thing is. Our previous speaker spoke about drone. So what does the drone do? It captures the images or the layered information of the Mother Earth from a height. So it gives us a digital output. Ultimately, it comes as a digital output. Here also we transform the surveying equipment's data into digital reality. Our agenda will be short today because it will take a long time to discuss about everything. So we start with the key application areas where our survey equipments are being used. So you see the application areas: land revenue, urban city planning, survey utility. Do you know what is utility? See, underground utility, pipelines, sewage lines, electrical pipelines, gas lines. Defense sector, disaster management, water resource management, forestry management. And then the lower row you find the GIS mapping, technical education, open pit mining, oil and gas exploration, heavy construction, infrastructure development. These are the main focus areas. There are other applications also. Now, can you find out the major differences between the upper row of application and the lower row of applications? Just one difference. I couldn't hear it. Anyway, the upper area application, the upper row application involves large scale mapping or large scale development. Anyway, okay. And the lower area of applications or the lower order of applications are more localized. GIS mapping you are not doing for the entire country, maybe one municipality, one village or something like that. Open pit mining, it is within restricted within the mining premises. Oil and exploration, that is also small, construction industry is also small. So the upper row applications, which were large scale mapping, where we get more application with GNSS, that is GPS or GNSS. And the lower order application areas, we can use both GNSS and GPS. Okay, these are all traditional equipments nowadays. So we start with total station or it is optical sensor because you need to see the target through your optics. Now this is our portfolio of offerings. There is a huge portfolio of different types of total stations. So we broadly classify into two categories. One is a manual and one is automated. So what is the difference between manual and automated? With the manual total station, you have to move the instruments in horizontal and vertical axis by yourself. The instrument cannot move for you. Whereas the automated instrument can move itself, it can rotate in any direction, as well as search the prism. Okay. So now under manual total station, we start with the starting model of PA0. This is particularly suitable for the educational institutes. It's a lower budget, but it solves all the gamuts of survey. So if the institute if you want to buy a large quantity of total station at a time, so that may be the go-to model. The next term is PA03 and PA07 with a software which is called FlexStream. That is why it is named as FlexLines total station. And then finally PA10, which is the topmost model of the manual total station. Now if we go towards the automated total station, PS13 is the starting model, then from PS16. These are the very popular models in India. Then come PM16. M stands for monitoring. That means it works unmanned. Suppose there is a dam wall or there is a load on the bridge. Pitch is probably sinking or there are some deformation taking place. And you need to monitor the movement of that particular magnet object. So you can put on speakers on different parts of the system and put a total station a little bit away. What does that total station do? It measures all the prisms, store the data into its memory. After 1 hour, again we measure all the prisms around the speaker targets. Then compare with the previous value. If there is a deformation or if there is a difference between the measuring values, beyond certain limit, then it triggers alarm. Say a dam wall when the water is rising, it is supposed to move. So if the movement is very high, then there will be a catastrophic problem. The dam wall may subside and the water will come down. So that sort of monitoring is done with the total station. It is unmanned, it runs every day, 7/24/7 to 365 days. Then come PH16, the most accurate total station in the world. Then finally we have MS60. MS is a multi-station. It has some other functionalities and total station. We'll cover all of them in the course of time. There is two more differences in between these two. One is a multi-person survey. In manual total station, a surveyor has to be behind the instrument. And there should be a survey crew will be carrying the prism of the rod to the object. So there will be at least 2 men required. So it's a multi-crew unit. Whereas with the automated total station, 1 man can also do. So that is called 1 man robotic total station. We'll cover that. Now very recently, within the last 2 months, there is a new model come out with PS20. And what are the advantages of PS20 also will cover briefly. Now a little more details of the manual total stations. You can see a comparative specification differences, but one thing that stands out is there is under PA07 you have a reflector-less range of 1 kilometer. That means you can measure to any object which can reflect light up to 1 kilometer without any prism. It can take measurements from a branch of the tree, it can take measurements of the rock surface. So without having gone there 1 kilometer away, you can still take a measurement. Others can take it up to only 500 meters. Now there are few more advantages of these like I showed. One is you see this is the horizontal drive and there is no clamp. So that is it is endless drive. So if you turn the drive, it will never end. It can move 360 degrees also. So this is called endless drive. You can directly insert a pen drive to transfer data. You can also insert SIM cards to get internet on board, and you can measure the height of the instrument from the ground through laser plummet. There is another optional feature that is called locking. So, for example, you are working in an industry and your site is very much away from your office. So, you are not going there for supervision of the total station. So, total station is supposed to be working within the periphery of the site. But all of a sudden, you find it is not visible. The total station has been taken away. It is been kept. So, in that case, this locking feature shows you can track the total station's movement. You can remotely track where the total station is going. You can remotely make it lock also, so that the person who took it away cannot use it. So this is locking. Now coming to the highest model of the manual total station. This is like a PX10. You can see there is a very large display and it's a 5-inch WVGA display with onboard 3D map. You can see the map here. Very detailed map. It can be seen in 3D, rapidly different. It has a very advantageous or very advanced coding system. So we can have line joins, line joining, polygons, actually everything is possible. Auto line feature, as I told you, it can generate its own or determine its own height by the laser command. And the software which is running inside this is Captivate software. And you can also run the third-party software. This is a big advantage. Now coming to make how protective these systems are as far as the environmental protection is concerned. You can see in the right hand side there are two videos running. One for dust protection, the upper one. See dust being thrown on top of a bucket or a stack of dust is being put on top of the instrument. And the lower one is showing the jet stream is fired towards the instrument. But after some time you take the dust and the water right away from the outer surface, open the instrument inside, there will be no water, no dust. And it is physically tested, just not a video. This sort of instruments are used by our military system. Philippines, even our neighboring countries also are using this for their military operations. And this has been physically tested by them. Apart from that, there are drop test, long distance, baseline test, cold chamber test, going minus 35 degree. So if you have to take this photo station and use it in the Antarctica or somewhere where the temperature is very low, so it should give you the result. So if you test it under the cold temperature as well as hot temperature where temperatures are over 60 degrees. Now coming to the automated photo station. As I said, PS13, PS16 are the more popular photo station in India. PS20 has come recently. This is with AI feature, artificial intelligence feature. PS16 and 16. Now, what is a robotic one-man photo station? First of all, you see there is no person required behind the instrument. Nobody is operating. So then who is operating? The person at the instrument. He is operating. And this is automatic, or it can move in the horizontal and vertical direction. It can find the prism also. Even if the prism is moving, it can track. So there is first you take a distance measurement to the prism and then lock it, then instrument will follow you. So this is called one-man robotic photo station. Now for this you must have two important features. One is the lock feature. See, there are two prisms, one behind the tree. The prism that I want or locked in is the one which is moving, and there is a large prism in front of the tree. But in spite of that, it is not shifting to the other prism that was locked. And there is a dynamic lock facility which is to lock to a prism which is even moving, and it was not within the pillar and it will just lock to it. Now, how does it then? See, the prism line has now behind some wall. So, what will the photo station do in that case? The photo station will come back to the position where the prism was last detected and wait till the sunlight comes back to that position. Once it comes back, it automatically relocks. Okay, these are the advanced features of the modern photo station. Now PS20, as I said, this is the newest addition to our product portfolio, and this has artificial intelligence features. I think it is not, the speaker is not not working. Anyway, just look at the video and wherever there is something I will just explain. So this, as I told you in the last total station, where you can take a measurement up to 1 kilometer without any prism. In this case, it has been extended to 1,600 meters. Okay, there are different varieties based on the age, based on the eyes, the camera. It has a 20 megapixel camera fitted over here. So if you take a photograph and from the images I can take coordinates. Just like the drone. You take the drone image and then you get a coordinate of the elevation of the ground. Here also it takes an image and it can take coordinates from that image. So now if you look at the data measured by total station and then you plot it in AGI software or CAD software, it will look like this. There will be a lot of points, lines, different types of features, maybe some lines, there may be some close lines, there may be some polygons. But can you, looking at this, can you really identify what the line is or what that particular point is? Probably not. But how it will be if you have a digital image embedded with this data. So now you can see what those points is. Right? So what is this? This is possible only when you can capture a point number. You can say it is a digital replica of the actual area. So we have got a total station which is the highest model of the total station called LS60, which has all the functionality of a total station. In addition, it has got a terrestrial laser scanning facility. Now you can see how it moves. It actually scans the area around it. It takes photographs and scans the area. And it is so accurate, it can also inspect the surface and identify whether there is an undulation. See, this is how it is scanning. And it can scan 30,000 points per second. Plus all the processing capability it has. Now there is another important thing. So normally what we measure a prism. We have to see the prism and then we measure the prism. But in normal cases the prism has to be perfectly erect. But we have got a new device called AP20 where it is not mandatory to keep your phone absolutely erect. So even if it is tilted, the instrument can identify, or the device fitted on the phone can identify how much tilted it is. So you always get the position of the phone tip. You might have worked with auto levels. How many of you have used auto levels or have heard of auto levels? But now auto levels is a purely optical instrument. You can only take measurement and read the values by yourself. But now it is converted into digital. So instead of a normal staff, it uses a barcoded staff. And instrument automatically reads the staff and stores the result. So there is no manual error anymore. So how it does? We just have a small video. It also has a camera. So you can actually see staff through the camera. Instead of actually seeing it through the telescope. Now we can see the telescope staff through the camera. You can have a USB for data transfer. This is the barcoded staff to which it takes a measurement. Just press on a button, it will take the measurement, autofocus to the staff and take the measurement and record. So it becomes very easy nowadays. So this is for there are many other instruments also, but I will focus on only this part. So these are optical sensors or optoelectronic sensors. Now we go to GNSS sensors. So you know what is the GNSS? So I am not going into details of that. System, yes. So if these are offerings for the GNSS portfolio. Again, there are two different parts. One is a GNSS receiver with separate GNSS antenna. This means this is a receiver and antenna is separate. And on the right side, you have integrated GNSS receivers with sensor fusion. That means here the receiver and GNSS antenna are built into the same unit. Apart from that, there are other sensors observed. Now, in this part also there are two parts. One with the field compensation. As I told you, with the proto station code, we have a device which can detect the field. Here also the instrument can detect its own field. Anything on the left hand side of the dotted line, they cannot detect the field. Anything on the right hand side of the dotted line, we can detect the field. Okay, so we will start from here, FLX 100 class, and we will cover to the highest one. So, to talk about field, so how the field is compensated, a little bit background info. In a normal case, for the traditional GNSS sensor, you need to hold the pole absolutely erect. And the position of the GNSS is actually determined at the phase center of the antenna. And then whatever input value of the pole height you have given, it ultimately goes down to the ground. This is a traditional input. But if there is a field, then where is the point falling on the ground? Which is much offset. It has a lot of offset from the pole. So there has to be some calculation or adjustment to be made. So how it is done? There is a sensor inside called IMU, inertial measurement unit, which helps to determine the angle of field. And there is a digital compass also built in, which actually gives you the azimuthal angle of the direction of the field. So finally, the directions are applied and you get the position of the pole. So this is happening in the background. You don't need to do anything, you just press one button. So start with the instrument which is FLX 100 class. It's a very small instrument, just the size a little bigger than this smartphone. And we have Android Air with it for data collection. A little more details of this unit. This is FLX 100 class. It tracks GPS, LoRa, Galileo, Baidu, UZSS, and also big direction from satellite-based augmentation system like Google. It can be operated through tabs which are running on Android or iOS or Apple devices, Windows devices. There are many different types of corrections profile. We can use the ports compatibility. That means Sun of India has established most permanent stations across the country, and you can get access to that directions and you get your position more precise. So you get exit corrections from dedicated days. So either we get a sub-meter accuracy or we can get up to 2 centimeter accuracy on position. It weighs only 319 grams. There's a 20-hour battery life. There is only one button here and one charging port here. There is no other interface except there are 4 LEDs. Environmental protection as per IP66, it can be used as a universal handheld device. It has a Bluetooth 5. The data can be recorded for post-processing purpose. It has an RTK update rate of 10 Hz. That means every 10 seconds we can determine its position. 10 times a second. Now this can be controlled by your own mobile device also, running a particular software. And it has a big correction specificity also, so it's showing the pin of 16 LED. The data collected is directly in shapefile format, so this is particularly suitable for GIS mapping purposes. So it can be used as an upright or as a handheld device or with the help of a pole. So it has an unlimited field facility. To carry the instrument like this, put pointing from the right point, press one button, feed the feature coding and other details of that particular point, then move forward. So this particular tab, this is not third-party tab manufactured by other devices. It is also manufactured by Leica, and it is a semi-rugged one. This tab can have the batteries exchanged. That means if you are working for longer hours, you can carry a spare battery and you can change if the battery is gone down. Or you can use power bank to provide power to both of them. So if you collect data, it can be put on a background image. By default, it comes with a DSRI world street map. So what you are seeing is a DSRI world street map, which comes as a by default. But you can also add your own map from RGIS Online, RGIS Enterprise, with map services like WMS and WMPS, or WHS and WHSP. So you can have your own background maps from these services. Now coming to another equipment which is slightly above this instrument. This is called GS05. It's a very small portable and handy GNSS which gives you very high accuracy, and this also takes care of tilt. So very handy system. You can see how small it is. It can be held within a palm. And taking point is just easy as it is. Put your pointing at the position, press one button and move forward. This is quite rugged, even though it looks small, but it's quite rugged. The only thing is that we can work with the only up to 13 degrees, only because to get the highest accuracy. So little more details of this GNSS, it can be used as an RTK reference, it can be used as an RTK rover, it can be used as an RTK cold rover or smart cold rover, which can also be used with motorized rover station. Currently, this can be used with Windows devices. It weighs only 750 grams. It has a 10 hours battery life, IP68 environmental protection, post processing of data, 10 Hz RTK update rate. Now coming to the top of the model. In fact, it is not top of the model, it is the top of the series, top line series. That consists of GS18, which is normally used as an article reference. It doesn't have a team facility. Then GS18T, T here is for tin, and then GS18I. You can see there is a camera over here. This is the first GNSS in the world to have a camera fitted within the GNSS system. So this is with feed as well as camera. Then what is the fun of having a camera here? So we will see. Now first we will see how easy it is to work. Surveying is as easy as it is. Just go to the point, press one button and move forward. It takes points instantaneously with an accuracy of around 1 centimeter in position and 2 centimeters in height, anywhere in the world. And if you look at the other side, it can take measurements to inaccessible areas where it was not possible to use a GNSS because of the canopy. And very near to electromagnetic influence. GNSS normally doesn't work near to very high electromagnetic influence. Now coming to the camera, how does it help? So for example, this person studying you has to take measurement of the pipelines within that ditch. But he is not allowed to go inside that ditch because there is 24,000 kVA lines passing through. It's a highly hazardous area, so he cannot go there. You cannot use a total station also. So how do you can do? So it normally uses the camera focusing that particular ditch and goes by the side of that ditch. And while he is walking, the camera is taking photos of that ditch. On the right side, you can see there is a trench being done by this machine. And they need to do a lot more to find out the volume of earth being taken away. So how do you do it? Again, the camera facing the trench, moved by the side of the trench, takes photos are taken automatically, and then both the cases the data is transferred to a software called LiDAR Infinity. Now, if we look at this software, so now it goes to the point where the trench was being done. You can actually see it in the form of a point cloud. Those images are now converted into a point cloud. So now everything is possible. You can take surface modeling, you can take contours, you can take artwork measuring between surfaces, make cross-section profiles, everything. It's very easy to do. You don't need to go inside the trench to take data. You just pass by the trench. GNSS itself takes photos, then stitches all the photos together, converting into the point cloud. So every pixel on the stitched image becomes a coordinate pixel. Okay. Now coming to a little bit of more software options, we have already seen the Infinity. There are other options like the Listed. It's basically a CAD software. You can do all the varieties of survey tasks with this. And Neo, this is an advanced version of this Listed software. The good thing is that there is a lot of discounts for the individual insurance. There are versions where you can have 10-seater models or 40-seater models. So you can use simultaneously in a closed land. So one teacher is taking the software and 40 other people can work together in an environment. So we have educational licenses for that. Now this Infinity software, it not only processes the data of GNSS, it it processes the data of total station, it processes the data of digital level that we are seeing. So it takes care of GNSS, total station, digitally, then imaging, we are seeing the data in point cloud. It can generate surfaces, it can infrastructure models, IFC files which are very common nowadays, adjustment of data and various other services. One of the services is that you can send the data directly from the field to office through internet. We have a geo cloud facility. We can upload the data directly from the field to office. Say somebody, one survey team has gone to Odisha, one survey team has gone to Tamil Nadu, another survey team has gone to some part of the remote place in Madhya Pradesh, and your office is in Kolkata. So you need to process the data of all the remote sites. So what you can do, you can come back from the site to your camp office, start the internet and upload the system to the geo cloud. The person sitting in the office can get access to the geo cloud data, he processes it and send it back to the site next day. Well, this person has been correct, this is, you are not correct, you do it again. It's not earlier what needs to happen, you have to come back from the site, then process the data, and maybe after 2 months you came to know, we have missed a major part of the area that we need to the problem. So we have to go back again after 2 months. Nowadays, it is very easier. You send it directly from the site, next day you are aware whether your data is correct or not. So a little bit details of the Infinity. Leica also has its own role, or rather Hexagon has its own role, but we don't sell it in India because of its high price. So it can also be drone images also. It can make surface profiling, contours. It can help excavators, GNSS data processing, quality control of data, and many more. So for Neo, if you look at this, Neo is a center, so it's a software which has interfaces with many other softwares and instruments. Like it can take data directly from composition, it can take data directly from GNSS, it can take data from Google Earth, GIS, DIM. You can be knowing the daily information from it. You can take data directly from CAD, LSCAD, XML, and other different software versions. So if you look in details in code, there are huge number of applications or software. You can explore it also. So you can also use the point cloud data directly. So this is a point cloud, this is drone images or terrestrial laser scanner data. Okay. This is panel data. So all everything can be processed using the software. Well, so last of all, we go to another category of surveying instruments or model surveying instruments. That is our reality capture solution, which covers dedicated scanning devices or leaders. I will not go into very details, but just touch upon the models. See, this is not an image. What you are seeing over here, this is not an image. This is a point cloud with embedded. So if you take your cursor to anywhere on this image, you will be able to coordinates. So you can say it's a digital replica or digital 3D layout. So which are the instruments that it is capable of? These are the instruments. Very small but handy. These are useful. Okay, little more in details. The BMK 360, this is a very small, just the size of this module, and it has only one button, just press it on, put it on a tripod to scan the entire area around it. And it will make all the images and the data that we get will have coordinates every week. Now, this is the handheld version of this equipment. So you can carry it in your hand. As you move, it scans around it. And its features scans automatically. This is again a type of this instrument called RTC 360. This is another type of this system called T50. These are slightly bigger in size. Now to start with BLK 360, this is very small and very heavy equipment. It is 0.75 kg. Okay, it has a field of view of 360 degree and 270 degree. Okay, the maximum distance can go up to 45 meters. And you can take 6,80,000 points per second. So if you put it over here and ask to scan the entire classroom, it will take only 1 or 2 minutes to scan. And everybody's face and glasses and everything will convert it into a one cloud. And you will touch your glass on the picture, you will get a coordinate. Now how does Now, if you have put it over here, after 2 minutes, you change your position. The scans, they need to be georeferenced on stitched with respect to common points and other technologies are there. You can walk inside as well as outside. Now, the same version is hand carried. This is called Go. It has a lot of cameras. In fact, 3 cameras, and it can take up to 4,20,000 points per second and a maximum distance of 25 meters. Okay, so how it works like? As a person is moving, it is scanning around it. And the most importantly, these scans are making speech with each other automatically. There is no separate georeferencing is required. Now the next upper version of this equipment, this is called RTC 360. It has both scanning and images. It has 360 degree and 300 degree vertical. That means 360 degree on the horizontal and 300 degree on the vertical. It can go up to 130 meters, and it can take up to 20 lakh points per second. So these are different levels of accuracy. Now, if you look at a little demo over here, how is it to use? There's a quick fix type of tripod like we use in the cameras. Just one button, switch it on. It has a tab. And the good thing is the data is streamed to the tab automatically. And what you are seeing is basically the scans are already transferred to your tab. The good funny thing is that when you are shifting the instrument from one place to another, it takes notice of certain fixed points, and on the basis of the distance from those fixed points, it generates its own new point. So if I explain it a little more detail over here, so this was my scan station before. Now after I finish scanning, I have moved to scan station B. So while it is being moved, it is taking measuring distances from two points, recognizable points, to determine the position of B on by itself. You don't need to fix it before. This is called beats. Now, where it can be used, it can be used in the building construction or modification of old warehouses or something, or maybe your public safety, that is accident scenario. Plans has been and redesigned. Suppose a new pipeline has to move through there. So, without disturbing the present condition, how and where the pipeline can be taken in. So, first you do a survey of this and then simulate your pipeline through that point down. So, finally, you go to the top model where P50 can has a range of 1 kilometer and it can store up to 10 lakh points per second up to. And this, as you can see the video, that it was a mine, open pit mine, where we are getting the digital replica of the open pit mine. It can be the building construction industry, it can be industries where you need to revamp, or this is the open pit mine. So it also stores the cameras. It's only 5.55 kgs. So how actually it works? A little background story. So it produces a laser which is reflected by this prism mirror, and then the mirror is also rotating. So a burst of lasers are actually being generated, which gets reflected from the objects, and those are seen. And each and every reflected object, the distances are measured, and then it is plotted in 3D. And you finally get coordinates of each and every point. It can be as close as maybe 0.5 centimeter by 0.5 centimeter. So what you are seeing, it's not an image, it is a point cloud embedded image. So it also restores the color and texture of the image as well as the coordinate element. Now this is showing how the georeferencing takes place. So 4 scans from 2 different places are actually plotted together as the georeferencing is done, and there are different methods of doing this georeferencing to finally to get a big, large. So with this, I end my presentation on modern survey instruments. If you have any queries, you can say. So these are the different uses: construction, survey industry, civil engineering, and open pit mining.
Please open this simulated one.
Okay. Okay, another important thing that is important to show here, because you are a very educational institute. So how do you teach this very student now? But someday you will be also teaching. So once you teach a large audience, how do you teach? So we actually provide you with some simulators. And this simulator, say for example, total station simulator, it does exactly what the total station software does. So it can teach each and every operation within the class to a large audience, and then they can take the instrument outside and do it as per their research. This is a huge advantage for teaching purpose. We have total station simulators, we have GNSS simulators as well. So once we order for total station or GNSS from the Education Institute, we give this simulators free of cost, which others may not. Any questions? Okay, thank you for all the patience here. No, as such, we don't have that facility. But once the student is ordered, we always give a credit to the main teachers or the one who actually brings the teaching part. So it's a teacher's training, you can say. So once it is done, the students are ordered, we give it free of cost. Thank you all.
Thank you, sir. In conclusion of today's session, I'd like to thank speakers, dignitaries, participants, and coordinators and committee members. In context of tomorrow's schedule, the session will be held at Rani Rashmoni University campus. Participants are requested to reach the Loknath station tomorrow by 10:35 a.m. The participants who are coming from Kolkata need to take train. The timing is 9:05 p.m. from Howrah. And after reaching the Loknath station, from there we will be going to the campus. And in the conclusions of the today's session, I'll ask our convener to say something about today's session.
Thank you very much for listening for last 3-4 hours. Tomorrow session is we have today we have learned about the drone and this mapping, geo mapping, and tomorrow we will get a chance on hand practice or on hand demonstration of the drone and this geo mapping. Both we will find tomorrow morning. Everybody at the Loknath station at in between 10 to 10:30 a.m. 35 a.m. and we will provide photo to take them take you everybody to the our university campus where actually the demonstration will be done, and in the afternoon we will take you back to the Loknath station for your downward journey. Thank you very much and stay well for the day.
I would